let's see some examples of NDVI use. And before that, just a quick coffee break. Not a coffee break, but just question break if anyone has a question. Okay, I will continue with some examples. Okay, this example was, well, there's an old slide from another presentation, Martha Swonitzer from Iowa Soybeans Association. We did a support job with about, I remember it was around 50 fields, where they have a Iowa STARS initiative. It's an initiative to improve energy efficiency, farm profitability. So they have a number of things that they provide advice for farmers. And one of the things they're working on is corn stalk analysis, which is after the season is over, there's a standard corn stalk test, which evaluates nitrogen management practices. So basically to see if there is low, optimal, or excess concentration of nitrogen. So this is a very simple application of NDVI. I will go to the Farm Service Center that you will be using during the course, and I will go to one of those farms or fields. So I just click on Farm Service Center, and there I will see a farm share with me. So you'll see later in the course that you can share your farm information as well, just by clicking on this members icon. So what we did is they wanted to evaluate nitrogen use. So instead of going to the field and taking some samples, what we did is, this was, so in July, August, we downloaded and processed Rapid Eye Imagery, which is one of the satellite systems that we'll be using. It's 5-meter resolution. So there, I'm going to turn on the Ndvi Imagery. And there what we could see, it's what we were mentioning, there's a relationship between NDVI and nitrogen uptake. So we see areas with that could indicate areas with nitrogen deficiency, others area with just enough or excess use. So this was a good guidance to guide the GPS, I mean going to the field with the GPS coordinates and then taking samples in those points. So this is one type of application that this was used for. Another example is how we're using this in Argentina. This is, it's similar to the Risk Management Agency, but not quite. The Risk Management Agency in the U.S. Provides insurance support. In Argentina, it's more like a technical support. They're not providing financial support yet, even though there's a product there to provide a comprehensive farm insurance or support farm insurance. So there they have, so this figure was taken from the Risk Management Agency in Argentina, and there they have, for instance, different areas with different crop cycles, and we can see, sorry about the Spanish, I didn't have time to translate, but it's right from the source. This is soybean in the west of Buenos Aires. We have a cycle that goes from November until March, and the consultants are using GeoAgro services and NDVI are using number one for evaluating variability in this stage here in R3 stage with the first sod, I don't know, So just before the end of the juvenile phase, just afterwards. So we have in R3 stage, which you will understand, it's what they use for evaluating variability within the fields, and we'll see that later on in the course. A product that's being generated is Protiviti Maps, which is a combination of Ndvi maps from the crop history. Number 2, in February, they are using this for yield estimation. Number 3, for stress assessment, either deficit or excess water. In this period, January for deficit, March, so that's when the hot summer, just like in the Midwest now, there's a hot summer there in January, and there's a deficit there that can be assessed, and March for excess water. Or, for instance, when we talk about corn in the same area, the west of Buenos Aires, the province, we have, they're using it for, so the cycle goes from September until February, and we have, in corn, additionally, we have in-season nitrogen fertilization. So they start after more or less almost 2 months after seeding. They start evaluating if there are areas that can be improved. The production can be improved through N-fertilization, nitrogen fertilization during the season. Again, we have in January evaluation of variability and yield estimations. Well, this is actually in December. There's an error there in the graph, in the figure. And number 2 is in just one month before harvest is the yield estimation, and 2 months before is when they evaluate variability. And also there are some critical areas for dry, for a deficit, or for excess water in corn. So these are basically the 4 aspects that they're using NDVI for. One example, when we say yield estimation, we can use regional models, or we can use a combination of NDVI and direct observations in the field, which is a combination of NDVI and ground truthing. We'll be moving forward towards regional models, which are much more, let's say, quicker and cost-effective. But for now, because we want to make sure that the assessments are correct, and because it is fairly new, we recommend doing ground truthing and following that. It takes some time and research to develop curves that relate NDVI and crops with the yield estimates. So for now, this is a method that we're using with consultants that request NDVI, let's say 30 to 45 days before harvest. And what they do is, for each type of crop, there will be parameters that you can relate with harvest. So there we, in this case, it's estimating in wheat. So what they do is they do an assessment in the ground of grains per spike and spikes per square meter. And what is done is to relate the NDVI with those parameters, and then an estimated yield map is extrapolated. So these are just some figures to illustrate that. So these are a number of sampling points where this information is collected: spikes per square meter and grains per spike. There's a relationship that's estimated between this spikes per square meter and the NDVI, and also the number of grains per spike. And finally, well, this is related with NDVI. We have found that there's strong correlation at that stage, 30 to 45 days before harvest, and then they can extrapolate relating the NDVI values, which is available throughout the field, with the sample points. It's just a simple extrapolation, and we have seen very, very good estimations between 0 and 10%. In this case, it's about 5% estimation. So just an example of how NDVI is being used for yield estimation. Are there any questions so far? And just let me do a quick check. Okay, so just a few other examples before we go into the unmanned aerial vehicles. Well, I'm just going to open a PDF with, so here what we're seeing is the infrared band. There's no NDVI, but just to give you an idea, where you can see at 5 meters, you can see the terraces. So now the accuracy, it's very applicable. 5 meters is a pretty good resolution for many applications. So this is from Rapid Eye Imagery, and then something that we'll see later in the course is creating Protiviti Maps, which gives an evaluation of areas with higher productivity and areas with lower productivity based on averages of past NDVI maps. So that's the second product that we'll be doing in the next sessions, in week number 4 actually. This is just to give you an idea about the resolution of how it plays out. So this is a 5 meter screen image. Well, we saw an example with 30 meters, and I'm bringing. You have a number of services out there in the web and in your region, different consultants, different companies providing this type of services. This was one that I chose. We are not in touch with them in time, but go in time. I think it's in the Southwest. But it's interesting because it reflects that idea of generating different information products during the crop cycle. So they have branded this product, the scouting product, which is initially in the initial phases of the crop. There's a product called Varisol, which is before seeding. So going back to Dean's question, this reflects different values of soil reflectance. Or scouting reports with highest and lowest biomass. So it's based always on the same principle. So when you get a provider, it's always interesting to and you'll see when we get to the end of the presentation how you can understand different systems by resolution, by spectral lengths, and by the depth that they're estimating. So here it's another. This is during the season where they, similar to what I mentioned before, where you have highest N uptake and lowest N uptake and nitrogen uptake. And it may not be a deficit in nitrogen, it may be another problem, as you know, as crop consultants. So there are different reasons, but at least this gives you good guidance to go to the field and do your evaluation and relate with your as I was mentioning before, something that when you evaluate nutrient deficiencies, maybe you want to relay those type of maps with tissue tests or soil samples. That's what we call the ground truthing, and see where the issues are and what type of corrective actions you can apply. Maybe this season variable rate application, or maybe for next season change some crop management practices. So and something very interesting, we got a request today from a client in Colombia, and we'll see this satellite. It's Politis. It's 0.5 meters resolution black and white or panchromatic, and 2 meters multispectral. So we're going to do a palm tree inventory. This type of application, these are applications that we haven't thought before because we were working more in corn, soybean, wheat, sunflower, sugar cane now in more tropical areas. But as the resolution gets higher, you will see more and more of these applications in higher value crops, and crops where or citrus or grapes or salads. Hello out there in California, I saw that you have almonds. So we'll see if we can get some sample imagery for your farm and see what things we can see with high resolution farms. So